What's up, everybody? It's Miss Wesley with Hyperbolas Day 3. We're going to start on page 30 of Conics Packet 1. And I want to start off with a joke. So your joke is, how do trains drink drinks? They chug. Get it? I feel like I almost need a laugh track to go along with these videos so that I know whether or not you guys think these jokes are actually funny. We only have one day left to talk about hyperbolas a little bit, and there were some problems we left out on page 30 of the Conics packet that I think are worth our time, and we're going to look at this page out of order, so if you want to join me, we'll start with number 2, which looks pretty good because it's in standard form already, but our job is to find all the important stuff, all the important features of the hyperbola to get a graph for it too. I mentioned this is already in standard form, so we know that a squared is always going to go for a hyperbola, not necessarily bigger than b squared, but it'll be with the positive of the two fractions, or some say that it goes first if you put the positive fraction first. That makes a the square root of 36, and x is with that, so you're going to go left and right from the center, square root of 36. B is going to be square root of 64, and that goes with the y's. And C has become the biggest of the three when you're talking hyperbolas. So by Pythagorean theorem, this is a 6, 8, 10 right triangle. And you're going left and right 10 from the center. Now, speaking of the center, I should have gotten that first, looking at the numerators, right? Center is going to be over at positive 3, positive 4. So let's put that on the graph. Over 3, up 4, we've got a center. To get to the vertices, let's go left and right 6. So plus or minus 6 is going to go with the x coordinate of the center. And so we'll go 1, 2, 3, 4, 5, 6 this way, and 1, 2, 3, 4, 5, 6 that way. Endpoints of conjugate axis. Let's use B to get those. Let's go up and down 8 from the center. So 4 plus or minus 8. I have to go off the graph a little bit. 1, 2, 3, 4, 5, 6, 7. Oh no, never mind. 8 that way. And then 8 this way. 1, 2, 3, 4, 5, 6, 7, 8. And this gives you a dotted line box that's going to help shape your hyperbola. So the midpoints of this box are the points we just plotted. Maybe I'll darken them in a little bit. Get a sense? You could put the asymptotes on the graph right now if you've got another color. You could switch over, and we know the asymptotes go straight through the center, and they connect the corners of that box we just drew. So this is actually enough to get a good picture of the hyperbola right now. Have it hug the asymptotes, right? The fact that this box is taller means the hyperbola is going to go wider. Yikes, it's got to touch that vertex. And the only things I'm missing, last two parts, the foci, we talked about how C determines where those are. You're going to go left and right 10 units from the center. So maybe this is where we'll have to spill off the graph a little bit. You were already 6 units away. Let's go 4 more. 1, 2, 3, 4. We could put a focus. And 4 this way. We'll have to extend this. So 1, 2, 3, 4. Over 2, where were we before? We'll be at what? 13, comma 4 for that last focus. And asymptotes. This is a hot topic for us. Most of the questions I've been getting from you guys have been advice on what's a good way to get equations of asymptotes. The easiest point, we know the asymptotes go through h comma k. They go through the center. So if you're using point slope form, you want to use the center as the point that your asymptotes go through. So y minus 4, y minus k, and then I'll leave a spot for the slopes, and we'll go x minus h, so minus 3. So that part's not too bad because you can always use the center to get those coordinates. You want the equations of both asymptotes, and they'll have the same exact slope, but one will be positive, one will be negative. This slope is either going to be a over b or b over a, depending on the orientation of the hyperbola. And look at the picture. Your easiest way to remember is to say, oh, am I rising or running a? Well, here, you're running a to get from the center to the vertex. So you're running 6 units, and you're rising b units. You're rising 8. Right? So whether or not you want to think about letters here, just think about the picture. To get from this point up to that point, right? You've got to rise 8 and run 6, like that. And I wouldn't want you to leave it like that. We could reduce it. You can leave it in point slope form, but we'll leave it as plus or minus 4/3 for the slope. X minus 3. Okay, we've got to try, I think it'd be good to try 3 together because we've got to try at least one question where we have to work to get the equation into standard form, and this is a good example. Some fractions are going to come up in this equation, so it's a good one to try together. Let's do what we would normally do. Let's leave the x's next to one another, and we'll put the y's next to one another. So you want the 36x squared plus 48x, leave a space to complete the square. We'll have the 9y squared plus the other y term, 36y, with a 29 on the other side. We've got some problems here. We cannot complete the square if the leading coefficient is something other than 1. So both of these numbers must get GCF'd out of the x expression and this guy of the y expression. So let's carefully pull out a 36. And we need a number. We need a number that you multiply 36 by to get 48. So 48 over 36 is going to go here in front of this x. And 48 over 36 would reduce down to 4/3. That's 48 over 36. And then we'll close the parentheses with a little space to complete the square. Now time for the y's. Let's pull out a -9. Y squared minus a 4y, right? We pulled out a -9, so you have a -4 on the inside. Leave a space, and we had a 29 on the other side as a constant. Now, we've got to complete the square and add half of b quantity squared. So half of 4/3 should be only 2/3, and if you square that, you get 4/9. 4/9 added here. And really, you're not just adding 4/9 to this side, you're adding 36 times 4/9. And if you multiply these, you get the number 16. Let's add 16 to the other side of the equation to keep it balanced. Now we want to figure out what happens here. Add half of b squared, so half of -4 is -2. Square it, you get 4. And we are subtracting 36 here. This is a -9 times a 4. So we will subtract 36 from the other side. Now it's time to factor. You have the 36 sitting out front. You've got a shortcut for factoring with completing the square. Same exact variable, the x. Same sign that you see in the middle, so a plus, just like there's all plus signs up here. And the square root of this number. So instead of 4/9, 2/3 is what it should factor into. Quantity squared. This one's a little more cut and dry. -9, I think it's a y minus 2 squared. And we'll count up the constant that we have on the other side. All this added and subtracted should just give you the number 9. So it's already looking a little bit better. Now let's see what happens in the end. We've got, we don't want to have a 9 here. We need this to be a 1. So we have no choice. We got to divide every single part of this by 9. So 36 over 9 leaves you with a 4 up top. We'll deal with that in a second. These guys cancel, so you just have y minus 2 squared over 1 if you want to show it that way, and it equals 1 on the other side. This would count as some sort of standard form, but it's easier to graph if we can see the denominators under the x's and the y's so that we can tell what a squared and b squared are going to be. So multiplying by 4 is the same exact thing as dividing by 1 over 4, dividing by its reciprocal. So your a squared is going to be 1/4. B squared, we mentioned, is just the number 1. If it helps to show it, you can put this as a fraction over 1. And this is the version of standard form, fractions and all, that we want to deal with when we're answering the questions about this hyperbola. So we'll try it. Center, numerators, let's see. We've got -2/3 for the x and then 2 for the y. We'll put that on the picture in a second. Vertices, maybe I should start listing a squared, b squared, or a, b, and c, I should say. So a squared is 1/4. A is the square root of 1/4, so that's only a half. You're going in the positive and negative direction sideways, 1/2 from the center to get to those vertices. If I add or subtract a half from that x, I'm just going to write what we get here so it'll be easier to graph. I'll put them over to the side, if you can see that. So we're subtracting a half from -2/3, and we get -7/6, comma 2. And if we add a half to -2/3, you're up to -1/6, comma 2. So this is what we'll use for vertices when we go to graph this. Endpoints of conjugate axis, we've got an easier job. We just have to add and subtract 1 to the y. So -2/3. 2 plus 1, so 3, negative 2/3, 2 minus 1, so just the number 1, and points of conjugate axis. What's next? Foci. Well, we said A was a half, B is going to be 1 up and down. With hyperbolas, we use regular Pythagorean theorem, so A squared plus B squared has to equal C squared. 1/4 plus 1 squared, so plus 1 equals C squared. C squared should be, we'll say, 1 1/4, or we could say 5/4. C squared, like that. And for this, we can add and subtract the square root of 5/4 from the x coordinate here. So I'm going to say for the foci, since this is a cumbersome value to write, I'm going to take the center, negative 2/3. I'm going to add, whoops, I don't need that comma there. I'm going to add and subtract the square root of 5/4, so the square root of 5/2. And your y coordinate is 2 for both of those foci, like that. Lastly, it's going to be the asymptotes. I still hold to my strategy that it's easiest to write the equations of asymptotes once we have the graph in front of us. So that's what I'm going to do. I'm going to just save the best for last, and then sliding that over a little so you can see it. Negative 2/3 plus or minus square root of 5/2. All right, here goes the center. Negative 2/3 comma 2. Just do your best to estimate. Negative 2/3 comma 2, about there. You're going to go left and right a half a unit to get to the vertices. So negative 7/6 comma 2 and negative 1/6 comma 2, like that. And really 7/6 is more like here, right? I drew it a little bit too far away to look like you're only going a half a unit left and right of the center. Up and down, you want to go 1 unit up and down from the center. So up 1, down 1 puts you up at 3. And then down at 1. That gives you the box that will let you graph this entire thing. So put the box here. And connect the corners, yikes, through the center with dotted lines. Just helps to decide how wide or skinny, I guess, these hyperbola branches are going to be. And this is a horizontally oriented hyperbola. So you've got the branches here and here. And then you've got out from the center, you've got, you're going to travel square root of 5/2. So you'll have foci about here and there, like that. Biggest thing was that you got the graph of the hyperbola on there, and it looks pretty good. Asymptotes, saving the best for last, like we said, use the coordinates of the center, right? The asymptotes have to go through the center. So we'll make it y minus 2, that's your k. Leave a space with a plus or minus for your asymptote slopes. And then we'll have x minus negative 2/3, so plus 2/3. Sort of painless there. And then the slope, right? The slope of the asymptotes here, it should be b over a, and you can tell that from the picture. You're rising 1 and you're running a half to get from this point here, the center, over to this corner. I like to choose that corner of where the asymptote goes through. So you are rise over run, you're rising 1, you're running a half, 1 over a half. That is also known as just the number 2, 1 over a half. So in point slope form, which is a fine way to leave this, y minus 2 equals plus or minus 2, x plus 2/3. I do think those are the 2 most important problems on the page, and it's okay that we skip the top one. Always a good one to come back to see if you could maybe take a strategy of solving both of these for 4x squared maybe and use substitution to solve the system. I'm going to post the key to this page so that you have the whole thing available, and then please, as always, if you've got any questions, let me know. Until next time, see you later.